Welcome, ladies and gentlemen. Thank you for joining today's webcast, extending the Tivoli ITNM discovery to include Telecom LTE network elements at U.S. Cellular. I'm Robin Ray, your Tivoli User Community Group Manager. As part of your community management team, I would like to encourage you to visit the community following this webcast to download this and previous presentations given to our member community. In this session, learn about the new ITNM elements, interfaces, and model components included in the ITNM 411 release and more interesting topics. Today's presenter is Barry Barron, Senior Applications Development Engineer at U.S. Cellular. Before we get started today, I would like to cover some administrative details. All phone lines are in listen-only mode. You may ask a question at any time using the chat tool. If your question is not answered during the presentation, we will address the questions at the end. Today's session is being recorded, and you will be provided with a copy of the materials following today's call. And with that, I'll turn the presentation over to Barry. Barry, take it away.
Thank you very much, Robin. And I'd like to, first of all, thank Robin and Jennifer for helping assist in getting this presentation going. I definitely appreciate the efforts. And I would also like to thank all of the guests who are joining so that we could share this information amongst the community. So if I may launch my window, there we go. Today I'd like to discuss the presentation which I presented with a co-presenter at the IBM Interconnect 2015 out in Las Vegas in February. The co-presenter was Matt Duggan from the IBM IT&M development team as a senior lead programmer. And the effort, I think, was very well received, and we had some good feedback at the end. So I also encourage any participation at the end for any Q&A. So the setting here is essentially that we have a need to understand what network elements we have out in our network, our wireless and data network. We are using the Tivoli product suite for our discovery and capture and retention of our configuration items into a configuration management database. The beginning discovery engine is ITNM. That's IBM's Tivoli Network Manager for IP is the specific release that we're using. And essentially, let me proceed now. And let me first mention that there probably isn't anything IBM specific in this particular presentation, because when Matt was co-presenting, he did present a roadmap. So in order to make sure that they weren't held totally accountable for any estimates in their roadmap, they wanted me to display this disclaimer. So in case there is any information about upcoming releases or anything, then this disclaimer is appropriate. Now, let's go sort of over the agenda of what we want to achieve today. I'll give a quick overview of what it means for the LTE model. And the LTE model, for those who aren't in telecom, is actually the latest wave of devices and equipment that support all of your smartphones. And I'll also go over some of the discovery model challenges that we've had in the past and what led us to our current release. I'll briefly describe some of the ITNM elements that are in the 411 release, and especially those that are particular of interest for U.S. Cellular's configuration management. Then I'll quickly go over a little bit about prior versus current discovery approaches, and then discuss some of the big wins that we see that we are achieving with ITNM 411 and another IBM Tivoli product in the SCCD, Smart Cloud Control Desk arena, our Maximo 7.5. we also include in some recommendations for the Tivoli product team. You got to keep those guys busy, you know. And then we will entertain any questions and answers. So to get right into it, the LTE network reference model, this is a very busy slide, so right now if people are squinting to see some of the detail, please forgive me, but our intent is not to actually go through this diagram in any type of detail. It's mainly to point out the new elements that were introduced for more of the IP routing type of devices in the telecom network. Before there were essentially the voice circuit type of devices, and now the focus is on IP, based backhaul under the LTE model. And so some of the new devices, are listed, and essentially we almost had to stand up a whole new parallel infrastructure to the current voice network. So quite a bit of devices, and another important thing is to notice that there are connecting lines between these devices, and on them they're labeled with the new protocols. And those type of protocols or topology layers are actually defined by the organization known as the 3GPP. And that's a standards organization, just like ANSI is the standards organization for a lot of other information. The 3GPP was specifically for the telecom LTE network and some of the new advances coming out. So without concentrating too much on this screen, we will boil it down to essentially the type of devices that we wanted to focus on in capturing our connectivity at US Cellular. Some of the important connections that we see are from one cell site, eNode B, to another eNode B, and that is known as the X2 connection. Then from essentially the eNode B through the cell site router, through an aggregation router, and into a device known as an MME for authentication. Another protocol we were interested in is from the eNode B through the cell site router, through the ag router, and going onto the serving gateway, the S gateway, as it is known. And from there, of course, then that's where the traffic will actually flow and eventually go through the S5 connection from the S gateway to the P gateway, which is the PDSN gateway going out into the internet. So these are the major components that we were interested in capturing. And to describe a little bit about our struggles in the discovery model from the previous release, ITNM 3.9, and what's known as the common data model within the Tivoli product suite, mainly within the TATM product and supported by the Maximo database. The previous model was and sort of is still very computer system centric. Everything looks like a computer system, a box with a chassis, a slot, a card, a port, and then some other features. Well, that did not really do well for emulating the new classes of devices that we have in telecommunications. One of the types of devices is the type that actually talks to the handsets, and that's known as the radio access network devices, and that's RAM. Those are the ones that actually communicate, as I mentioned, to the handsets and then transfer the information back to the main computer core network for routing and authentication. There are, of course, the various LTE class devices, as I mentioned, like the eNode B, the MME, etc., that follow along with the 3GPP logic. So there was also no easy way of sort of extending the IBM computer model. So whatever was designed into the system as far as describing a particular device, you were pretty much locked in with that mechanism, and we actually spent quite a bit of time in finding out how to augment the model with things known as additional attributes, or in the world of TADM, they're known as extended attributes. So these were for getting things in that were either additional elements to describe the actual base element, or they were non-discoverable attributes that we wanted to capture about a device. So, in bottom line, it was pretty much like trying to fit a square peg into a round hole. We really struggled in getting the radio access network type of information, the LTE, and those connection lines, the 3GPP connectivity mapping information into the system. So, in working strongly with the IBM's IT&M development team, they essentially used quite a bit of our network information in order to help them model a nice LTE platform. And they've also came out prior to the LTE platform, they did do a radio access network, a RAN release in ITNM 4.1. So the actual model or modules that they put in their focus to be able to model were the big dotted line over here, illustrates the major elements that I had mentioned we were interested in. The eNode Bs are connected over on the left-hand side with the 4G symbol over there and the X2 connection. There is the eNode Bs connected to the MME and the S gateway, and then the S gateway to the P gateway. In addition, they've also included another device that helps essentially regulate the flow of information to the P gateway, and that's the PCRF. And to support some of the authentication mechanisms in the MME, there is also a connection. If you look at the upper dashed line, you will see it extends out to the HSS and EIR type of device, which is merely to help in validating that the user has, proper account set up, et cetera, on the network. So those are the actual modules that IBM has modeled in their ITNM 4.1.1. And just to let you know, what does that mean to extend the model within their platform? And what they have to do is essentially describe the entity relationships between the various pieces that comprise, the device makeup, all of the different attributes and how they function and the different component layers. So again, I don't intend on going into any detail here, so in case your eyes were rolling back on this one too. Essentially, it's just to mention that they had to do quite a bit of extra modeling by looking into the various manufacturers and come up with common concepts between the vendors, which is a big challenge in and of itself, in order to describe what are the individual components and how to include them in the model. Another aspect is what is the focus of the traffic going through the devices. There are two major focuses. One is known as a control plane, and that is essentially when you use the actual automated mechanisms within these devices to set up the path for the traffic to actually flow, for your voice or data to actually go through the network. That is known as a control plane. Then there is the aspect of the actual traffic, your voice or your YouTube videos or whatever they may be, is actually the LTE user data plane. So they had to keep in mind the two major paths for modeling the information. This is a example of how we had a previous implementation of our discovery, not only going through the original ITNM product, but actually through a series of Tivoli products. So the very first thing we had was the ITNM for IP, in which case we would actually go to the, typically we would actually go to the OSSs, or the element management systems, that the vendor would provide that generally controls their network elements. Sometimes you can go directly to the network elements, but you can imagine if you have traffic flowing through your network elements, you don't want to be disruptive of the network elements themselves. So oftentimes it's favored to go through the operating system, or the OSS, or the EMS, the element management system. This essentially, in order to get the information, that we would execute a command on the OSSs and produce an XML file giving us configuration information. Well, then we would have to parse that information and then supply that information to the collectors in ITNM to be read in through the discovery process. Once it went from the ITNM into the NSIM database, which is ITNM's database, we would then flow through the TADM discovery engine, which is Tivoli's asset discovery, and I can't remember the exact name now. The acronym is essentially its main purpose is to discover computer systems and the applications running on the computer systems. And the benefit that that gave us was that there is an organization known as ITIL, and essentially ITIL describes sort of in data interchange format, which IBM has termed their common data model. So in the TADM database, there is the common data model. Then we would use a product that is the IBM Tivoli Integration Composer, or ITIC, and that product would actually transfer the information from the TADM database into the Maximo database, which is our Configuration Management Database, or CMDB. And at that time, we were using what IBM had packaged as TAMIT, the Tivoli Asset Manager for IT, in order to access information and perform operations on that data in the database. So now under ITNM 4.1.1 and the new SCCD, the Maximo 7.5.1, essentially our use of the parsing is actually optional right now, because IBM under ITNM 4.1.1 actually developed some collectors that reads the XML file directly. So that alleviated us from having to do some additional work. Then we still could actually pass the information from the NSIM database into TADM if we so desired. But at US Cellular, we decided at this point that is not a necessary step. So what we've done is we've actually extracted the information from NSIM and use ITIC to go directly into our configuration management database. And there, the new product that TAMIT was sort of relabeled and repackaged, and now is the Smart Cloud Control Desk, SCCD. So you could see that not only did we alleviate perhaps some of our additional parsing, but we have also been able to cut out one of our steps in order to go more directly into the Maximo CMDB. This now gets into a little bit under the hood type of thing. So please, excuse some of the busy detail, and more will be popping up. But essentially, the phases that we go through in our discovery were the data collection phase. And as I had mentioned, this is where we would gather information from our vendors, and we would parse the information in order to provide it into the CSV collectors of ITNM. So this was our responsibility to do all of that XML parsing. And this, again, is the previous version, the ITNM 3.9 version. We were using a SOAP collector to access our ALU SAM 5620 information. That's an OSS for the Alcatel-Lucent type of routers. So we did employ the IBM's SOAP collector. So they had a collector that we did not have to write information for. And then they also allowed us to do SNMP type discoveries on network elements. At that particular point in our previous release, we were not implementing that. So this just goes to show you that the original phase is to be able to collect the data from your network elements. And this put it into in-memory databases within ITNM, and they're essentially the collector details and the collector inventory. The next phase is then running a discovery process, wherein the collectors talk to the main engine and store things through a myriad of other in-memory databases as it marries up information endpoints. You need to know what connects to what type of stuff. And then it stores all of that information into the NSIM database. In the previous release, we would use a utility provided out of the box by IBM known as the NCP DLA, and it would produce an XML file. The XML file would then be transferred over to TATM, and then the TATM engine would load it into its database. And like I said, it sort of put it into that ITIL Foundation's Common Data Model format. From there, we used the ITIC process, wherein we mapped it into our Maximo database for storing as a configuration management database. Now, how does that differ from what we're doing today? Well, today, we still could take advantage of the CSV collectors. However, now we have the new XML collectors provided by IBM so that we do not have to do the additional parsing on our major vendors. The SOAP collector was actually enhanced to be a lot more efficient and reduce its processing time. And we are actually going to employ some SNMP-based discovery for some of our routers. But again, it stores it into the collector information, and as you've noticed, they actually extended the model, so now there is a new in-memory database as well. And then the information will flow to the next phase, the discovery process. Well, in the discovery process, it flows through less in-memory databases than were necessary before, and in addition, they have included now to actually utilize this entity details in-memory database. And that is actually a very key part where they have written a Perl utility in order to load information into the entity details table. And that entity details table is really a key and then a name value pair. So by supplying the proper key, the Perl utility, essentially using SQL type commands, will actually marry the information from the entity details, those name value pairs, and associate them with actual entities in the working entities table that it received from the collectors. So now we have a nice, easy way of adding extended attributes or additional attributes into the system. And it allows us to, quote unquote, extend the data model by tagging on these additional attributes. And then, of course, the information flows through the processes, the discovery process, and ends in the NSIM database. Well, from the NSIM database, we still do an NCP DLA extract into an XML file. However, now we do not need to process through the TADM system, and instead we go through an ITIC process, which will actually load it into the CMDB, the Maximo database. So that is another enhancement where ITIC could actually access information directly in the XML file instead of having to coordinate with the common data model engine within TADM. Okay, I hope I haven't lost you in getting into too many of the weeds here. So let's just sort of recap some of the extra benefits that we've been able to attain. Previously, in order to make a configuration change for an additional attribute, we would have to change 4 different configuration files on the ITNM host, and we would have to go in and define that attribute in the class structure within TADM. Well, with the 4.1.1 release, now we're able to take advantage of that entity details mechanism that I had mentioned and be able to just load information through that one Perl utility without having to do a lot of or any other additional configuration. So once you've essentially loaded the SQL instructions within that Perl utility, then you can keep loading as many different attributes as you would like for those particular network elements. And this essentially, the actual Perl utility was developed by the co-presenter that I had at the interconnect, and that was Matt Duggan. So Matt Duggan himself actually wrote the utility, and he sort of detailed here the process flow in which it uses the entity details table, marries things up with the entity data, and then provides a nice common picture and totally intertwined within their discovery process. And there's also a QR code so that you could actually download the actual Perl routine and use it yourself. So if you have a copy of the slides, you could use that QR code and actually download the actual Perl utility. And just to let you know how they've then extended the NCP DLA utility to extract the additional information, because before, of course, it was dealing with computer system type information. So now that we have these new LTE elements, one of the things is we want to take any of the extended attributes that we've tagged on, to our entities, and that's merely including one additional line in a properties file. That's how easy it is to be able to tell the DLA extractor to extract the information within the entity details. So one line configuration change. And then if we want those LTE model components, if you're using it for LTE purposes, then in order to include those LTE modules of MME, eNode B, etc., then you have to include one additional tag at the end of the parameter line for the generation filter. So that's how easy it was to reconfigure the NCP DLA utility in order to obtain the new information that we were interested in. So now let's go over some of the nice highlights that we've seen now with the ITNM 4.1.1 release. Well, of course, they had to expand the model and include the new classes and the data structures to accommodate the radio access network, which is really telecom based, and that was actually done in release 4.1. And then the LTE modules, the eNode B, MME, etc., and those are under the 4.1.1 model. And that includes the 3GPP topology of that S1-MME, S1U, X2, those type of 3GPP terminologies is also built into the product. They've developed some new collectors so that we do not have to parse the XML files in order to extract information into a CSV format and present it to the collector. So now they've actually alleviated us from doing quite a bit of extra work. They have, again, used the mechanism of loading the entity details table, not only for using the extended attributes, but it turns out they've actually chosen to use it for their own LTE model extensions. Instead of having to do a lot of extra components, they found the same feature, a nice feature, so that they could use it for their own internal model development as well. So that was a key win for both us and the base IBM product. And then, of course, the NCP DLA utility, so that it allows us, after just making those little configuration changes, now we can extract the information and have it loaded directly into Maximo via ITIC. And then, of course, they have the new topology layers, as I mentioned, that 3GPP type terminology, as well as depicting separate control planes, so that if you want to know if something's not controlling a device properly, or the user plane, if data is not flowing properly through the system, they have the visualization in what's known as the TIP GUI, which is the Web GUI component of ITNM. So it's the network visualization tool. And now, let's see exactly how we benefited from all of those additional enhancements. Well, certainly, we no longer need to pre-process our XML files if we decide that what is now in their base system is adequate. Currently, if we still found that we needed to get additional information out of those XML files, we may still need to do some parsing and present it to that Perl utility. So I can't guarantee that we wouldn't still have to parse the XML file, but if we're satisfied that they have an adequate model, then we no longer need to parse the file. Then there is the no additional configuration every time we wanted to add an extended attribute or an additional attribute, some other feature. All we have to do is present that information in a key name value pair type of mechanism, actually a CSV file, and then make sure that the SQL statement is adequate to marry it up with its base entity. So as long as that information is, that key information is already configured in the system, all you have to do is just keep adding additional attributes. You no longer have to keep configuring the system. And then, of course, they improved their ALU 5620 SAM SOAP interface by a mechanism known as find a file. So instead of being conversational SOAP calls, it actually writes the results to a file and then pulls it in, and therefore it actually improved the processing time immensely. There is the, just in general, through fixed packs or patches, they've actually been able to increase the ITNM discovery processing, the marrying up of endpoints, etc., and they've definitely improved the inner product workings. And as I mentioned, I think in the previous slide, that they have less of those in-memory databases. So you can see that through optimizing and getting a better performance mechanism, they've been able to actually eliminate some of the steps that they had to go through before. And then there is the LTE elements and relations that they've included in the 411 product and made sure that they were extractable in the DLA file. And then we've also eliminated and this is more of our choice at this point from US Cellular's point, we no longer need to process the information through TADM in order to get it into that ITIL common data model. Instead, the mechanism that now they've made, the adapter that they've made from ITIC to actually read the DLA file, will still put it in an ITIL compliant format directly. So we no longer need the resources of TADM in order to get it into that common data model format. And then, of course, the ITIC loader itself, they worked on and provided some performance enhancements. So bottom line, what management typically likes to see is, what has it really done for us? So in our previous ITNM release, it was taking almost 78 hours in order to get an end-to-end discovery. And that is because we had to go through our actual XML parser, then we had to do the ITNM discovery, which at that time was taking almost 24 hours. We had a DLA extract process, and then we had to load it into TADM, and then we had to proceed, to use ITIC to load it into our CMDB. And so that was a total of 78 hours. Now, I had mentioned that we may still want to do some XML parsing. So to be honest, I gave it 2 hours under 411. Although if we wanted out of the box, we could use 0 XML parsing. Then we have our ITNM discovery, and as you've noticed, they have done some excellent performance improvements, gotten it down to 4 hours. The DLA extract is approximately the same amount of time, but now we are no longer going through TADM, so we avoid that expensive load time, and the ITIC process immensely improved, and so that results in now a 10-hour end-to-end discovery cycle. So that is definitely within the realm that we were shooting for. Also within the product, there has been some new visualization to let you know what's actually going on during the discovery cycle. And there are some graphs that you can view online, and they will tell you if you have a certain bottleneck or a performance issue at a specific point in time during the discovery process. And then you can work on it. It might be network latency, or you find out that at that same time your database was being backed up across the network, or something on that order. So you can investigate more and get your discovery time down even more efficiently. So moving on, we actually have some recommendations to IBM. And I wanted just to point out how well we've worked with IBM, and that they've actually been listening to things we've said, because these are some of the recommendations we had from prior years. We actually said we would like object structures to actually be implemented so that we could model our RAN and LTE devices. And of course, provide collectors or agents to support that so that they can actually input the information or consume the information from the vendors. And indeed, as I had mentioned, IBM delivered 2 new collectors that we are utilizing and now no longer need to parse our individual information. Actually, that goes more into this part, the utilities, where we actually asked for perhaps them to give us some base scripting type utilities so that we could interface better with the vendors. But in lieu of this, they actually developed the whole collector to read the XML file. So, but they did also develop the Perl utility to help us load as well. So that is really an extra benefit as well. Let me get my mouse going there. So indeed, they have developed information, perhaps based on our recommendations, or it's something that they already had in their roadmap. Another aspect was, in order to put things through the TADM process, required us to conform to whatever TADM had as restrictions in their data model? Well, it turns out for these extended attributes, you could only attach 101 attributes to a specific classification. Not 100, but 101. So, there is still that limitation, and we think that perhaps they could redesign it so that it's just an unlimited array, and we would still be able to utilize that common data mechanism, that common data model. So, there, as far as things go, in the ITNM, the entity details is where you store those additional attributes or extended attributes. And that does allow an unlimited name-value pairs as long as the key and the name is unique. Then you can store as many pairs as your database could hold. However, TADM's common data model, the user data is the actual table that holds the extended attributes, and it is limited to the 101 items per class structure. So that is a bottleneck. So ITNM has done their piece, and what we are asking is that the TADM team maybe step up and perhaps improve their product to be more dynamic array type of modeling. And what are some of the other recommendations we have as a telecommunications provider? Well, we would like to see them continue to extend the LTE model. If you remember, one of the first screens we showed was what type of devices were in scope for the 4.1.1 release. And that had that dashed line. Well, there were evidently a number of other LTE components that are available to be modeled, and some that weren't necessarily depicted at that higher level reference architecture. And some of the recommendations we have are, there are actually additional components between the eNode B, or often known as a base station, and the antenna itself. So there are some devices that help control frequencies going out onto the antenna, and we would like to maybe see some of those modeled. And then there's also something that helps the system configure and determine which of the, as we noted through the control plane, which is the S gateway that you would talk to as an eNode B, and which P gateway, which PDSN gateway would you talk to. And that is done through a device known as the EPC DNS. So it is typed like your typical DNS servers in your environment, where that actually returns information based on a key that you send in. And that type of information, though, is used for routing purposes. So we would like to see them model that, because that to us seems like a key piece in the configuration. Another of the technologies that's coming out like gangbusters is known as VoLTE. That's Voice over LTE. And of course, the LTE is the new platform, so now we're doing Voice over LTE just as they did Voice over IP. So it's the Voice over IP implementation for LTE systems. And there are many different component pieces. However, they don't seem to be all that different than existing components, such as a lot of them are like router type functions or behave similar to like an MME, an authentication type device. So we are hoping that they will be able to include this whole myriad of devices into their model in the very near future. And then looking a little further down, what we'll call a strategic need, are things where we have things known as small cells. These are types of devices that may be like available for maybe your neighborhood block, or perhaps being installed maybe in a business location, so that you have your own little almost router type mechanism and data access point into our network. So that's small cell, and you can imagine there could be lots and lots of those devices. And then another aspect is we not only need to consider getting the information about a device itself as far as what the device looks like, a configuration model, but we also need what's known as geospatial aspects. And that geospatial aspects are things like the latitude, longitude, what direction the antenna is facing, and even to the point of how much down tilt it might have, because that might mean the area of coverage that is actually available to that particular antenna panel. And of course, all of this information needs to be tracked down to what we know as the sector, or essentially antenna and or sector and cell level. So that we're really looking for that, and especially one big win if they include more of the geospatial aspects is it really makes great mapping. And there's nothing better than in a presentation to show a nice slick map with the way that the antennas are facing and the area of coverage, and if they overlap or don't cover a region and people's phone calls get dropped. So that's a big win if they can include that somewhere in the future. And along with that, then they would be able to possibly get down to the attributes that actually indicate whether or not there would be a collision. Think of it, if you both picked up a CB radio and tried talking at the same time, you're evidently going to talk over one each other. So it would essentially, you can detect whether or not you would get a possible collision, or if you have a neighbor in the area where you need to hand off because the person is mobile and they are going down the road and you need to hand off to a neighbor, there are a lot of parameters that say who are your best friends to hand off to, and things on that order. So there are a lot of these collision detection, handoff relationship type of parameters and metrics that could be analyzed if they provide more and more support, analytical type of support and metrics for things like that. And then one other mechanism here is to essentially be able to include additional configuration items using the collectors that they provide. So their collectors right now are not necessarily tailorable. There is no open list of items they are including out of the XML file and what they map to. It's behind the scenes that they do that. If they were to expose that in a configuration file to the end users, then we would be able to actually maybe extend the model automatically by saying, okay, we still want this additional field from the XML file and map it to this particular object structure in the entity. So that's some recommendations for a little bit more of a strategic need. In summary, I just want to mention how beneficial it's been to work with the IBM development staff and see features that we've worked with them on actually make it into a GA, generally available release of a product. And essentially, by taking into some of our recommendations, such as using the entity details table, they've actually not only, listened to us for our need, but actually ended up using it as one of their base mechanisms now in their own model. So it really makes us as customers feel like we do have a voice in the process. And not only through presentations, such as at what was Pulse before and is now Interconnect, but also with the Customer Advisory Council, the CAC, which is a special session at the end of the Interconnect, where they have just as many IBM managers and development staff as there are customers. So IBM is really interested in listening to the customer's input and finding out some of their pain points or perhaps what we would like to see in their future roadmap. And of course, I think as a vendor, IBM doesn't just program things in a closet, that they're actually getting some true customer use case exposure and can tweak their product to more properly match the customer's needs. And then there is the various modified or developed features, such as that Pearl collector, which Matt Duggan wrote, not only benefits us as a telecom provider, but anybody else using the ITNM product that needs to attach additional information to their devices for whatever it is, for utilities, for any other purpose, they can now do that in a nice, easy fashion because that product was developed and now is available to other customers and clients. And as I mentioned, there was that QR code. You can go and download it yourself if you are a utility company or some other company using ITNM. And the bottom line, one of the things, again, that management likes to hear is that through these new improvements, we've been able to not only decrease our discovery time, but just the cost in our time to configure the system and to run the system through its discovery processes decreases. So therefore, that's a big, time and money saver. So I can encourage all of you out there in the community to reach out to your IBM staff and collaborate with them, communicate your needs to them, and connect with them with information, give them information so that they can better prepare to enhance their product that will be very beneficial to us all. Okay, and I think at that point, we are now ready for any questions and answers.
Wonderful. Thank you so much, Barry. Just to remind everyone, if you have a question, please use the chat tool, and we'll get to your question. We have our first question coming in, and this kind of is out to everyone, so if anyone else has an answer, feel free to type it into the chat. But does anyone know if that ITIC adapter supports other CMBDs such as Remedy or Trium, since it's in ITIL format now?
I don't know if anybody else has any expertise on that. I do know that there are various adapters available, and we would probably have to reach out, to somebody from the ITIC team, or if you open up a PMR, they will actually assist you in tracking that information down. You don't have to have an actual problem. At least that's how we use PMRs. I don't know. I'm hoping we're using them appropriately. But sometimes if we have like an investigative question, like how can I connect the system to this third party, we open up a PMR and they'll let you know whether or not they already have an adapter or whether or not, that would be something you'd have to ask services to develop.
Okay. Thank you, Barry. Another question's come in. Any RCA correlation within 4G network implemented?
Actually, we are trying to do that. That's the whole idea. Right now, we've really focused this particular discovery mechanism around the LTE elements. We have actually another cooperating ITNM system that is not only running our netcool alarming, our fault management, but it also does some of the core routers. So we are trying to get to the point where we pull all of the core routers in with the LTE information. We first wanted to keep them separate because LTE coming out so quickly, we didn't want to introduce a network element that could crash our netcool system. So, but that is the intent, is we are going to do, and that's a very nice segue, by the way, is the ITNM team has developed quite a bit of cross-domain stitching. So we could actually take the domain that we have from our I'll say our core routers and stitch it with information from this LTE development, and then that would provide a more holistic configuration, a topology, and be able to provide truly not only a visual map using the ZIP Web GUI, but also assist in doing more root cause analysis. The base, and I'm talking maybe a little beyond my scope here, but this is sort of what I've gotten out of some of the conversations with the IBM staff is the root cause analysis type of features within the omnibus, the NetCool piece of it, is actually based off of elements that are in your discovered model. So right now, since we have our LTE equipment really just going through the ITNM discovery engine and not currently connected to our NetCool omnibus information, we would not be taking advantage of any root cause analysis inherent in the omnibus and NetCool product. However, once we join our two domains, and that may be as simple as leaving each domain running and just doing this cross-stitching, that's something we have on our roadmap to discover. But then that root cause analysis would extend to these LTE elements as well. So I think that there is the capability, it's built into the system for entities that are in the discovered model, is what I believe it needs in order to do a true root cause analysis. So that hopefully answers the question, and please reach out to IBM for more detailed information.
Okay, great. So our next question coming in is, can we do integration of ITNM 4.1 with LDAP? And if yes, then how can we give the roles to the domain users?
Okay, that's a good point, and we've essentially done that with our SCCD. Now, I don't know if you only have ITNM as the only IBM Tivoli product that you have in your environment. However, you essentially need to do it through a WebSphere component. And so for us, since we are using the Maximo environment under SCCD, what we do is we actually have a module or a feature deployed with the WebSphere, and it's called VMM. That's Victor, Mary, Mary. And that VMM product allows you to attach to either, like in our case, we attach to our corporate LDAP, and we could do a separate Novell Active Directory connection. I know in a previous instance we actually had it connected to both. So if you have a Microsoft LAN-based system or whether you have some other corporate LDAP system, you can connect. It's usually under the WebSphere component. I know the TIP Web GUI is actually some pared down version of I believe a WebSphere component. So it may be able to be done. You can again reach out to perhaps services or something like that, IBM services, in order to understand how to do it, or there's should be white papers out there. But investigate the tool called VMM, and then what we do is we would define, and first of all, you could do filters. So depending on what type of groups are assigned at your corporate LDAP level, you would ask your corporate LDAP community to be able to register new groups or roles to be able to allow different functionality within ITNM or SCCD. So, for instance, if you wanted to partition, devices based on, perhaps domains off of regions, so you don't want one person, accidentally getting confused or changing something in another region, you could provide those roles as groups in LDAP, and then control the actual use through privileges in ITNM. But again, I know that we do it. I'm probably a little bit beyond my technical scope to know the granular details of assigning those, security groups to the users for different, functionality. But there should be some nice information out there. Like I said, check the WebSphere VMM component and LDAP integration for Tivoli products, and we know it can be done.
Thank you. And our next question, let me just make sure I haven't skipped anyone. How is telecom industry planning to use or using cloud and SDN in LTE 4G networks?
Well, that's a very good question. I mean, first of all, right now, as you may understand, LTE is really IP-based switching and routing and transfer of information in the back end. Before, they used to have to be dedicated voice circuits where you had to set up a point-to-point connection before you could start talking. Now you could start sending packets at any time type of deal once you've been authorized. And since that's the case, we have the availability to actually, and your phone may be set up to actually go and use Wi-Fi networks, jump on Wi-Fi networks and be able to transmit some information directly through Wi-Fi. So you're not really using the telecom provider's network, you're using the internet. So there are some solutions as far as that goes. As far as using the cloud per se, of course, IBM has a lot of their products that they are pushing for going to the cloud. In other words, they will manage and maintain those devices, and then your company has access to it, and of course it's a secured and locked down type of feature. And that allows the ability to, what they say is be able to push releases a lot quicker. So they call it constant release type of benefit. So it's great that they're maintaining it. They're responsible for doing all the patching and everything. However, as a telecom provider, we're always leery about invasive attacks. And anytime you go to a cloud, no matter how much they say that it's locked down and secure, one thing that came out at the Customer Advisory Council is most public utility and telecom providers are still very leery about the very intelligent hackers that are out there. So we use quote-unquote internal cloud type of concepts within our systems when it's only our local offices type of thing. But for any time we go to a workforce that may be extended out to third-party providers of telco circuits and things, we have generally not employed any cloud-based mechanism to extend out into that type of area. The only thing we have is for dispatching work orders to our technicians. So we do have a beginning, and maybe the industry will accept it more if it's proven reliable. But if you take that gamble and you get hit, it can really knock your market share down very fast. So we're very cautious.
Thanks, Jerry. Good. And our next question, with 10-hour end-to-end discovery, how often do you do full discos now? Oh, sorry, my screen got moved. Discos now, and do you do partial discos, and how often? I hope I'm pronouncing that correctly.
Yeah, yes, especially with the times that we were running into before. We were looking into doing partial discoveries, and essentially we sort of did that in order to get information in quickly because we found out our information was getting stale, at the endpoint in our common, our configuration management database. And when people, especially when they're turning up new devices, they want to be able to see that information to marry it up with fault management and performance management. So currently, we always had it designed that we would do a discovery once a day from our major components, and that was sufficient for some of the configuration information. When we get down to a lot more of these type of devices that are either going to be quality of service or other types of mechanisms, and one of the things we ran into was in licensing, that if we went over a capacity, we only had so many hours to actually buy a new license or take some of that traffic off of that particular device. So we found out we weren't reacting enough, and we would actually have our device shut down by the license management system. So we do realize that we are trying to get more discoveries per day. If we can sustain this 10-hour discovery cycle, we would like to get at least 2. And we've been toying with the idea about doing discovery as necessary on certain devices, and we were trying to see if when a device is changed in an operating system, in some network element, if we could receive an SNMP trap that indicates to us, hey, there's been a change on this device, and then we could go out and just discover those devices that sent us those configuration change traps. So we are trying to see about configuring the system to take advantage of that as well. But right now, we truly only do the discovery once a day.
Great. And just to point out, we are 5 minutes past the hour. Barry, we do have a couple more questions that are in. Do you have the time to continue answering them, or would they be best to send to you through email?
If they have the time to listen to me, I'm here.
All right. Well, let's keep going then. So here's our next question. How many IT&M domains do you have, and do you use the cross-domain view, and how useful do you find it, i.e. pros and cons?
As I had mentioned, we actually have 2 IT&M domains, at least in the engineering area. Let me tell you that we also have a regular IT group that supports the billing systems and the marketing and sales, and there is an IT&M even over there, but that's not even within our realm to include in at this point. But just within the domains that provide our true overall engineering network, as I mentioned, we have 2 domains. The one is really the core router type domain, and that's the one that also runs the NetCool system for the alarm panels to our network operations center. We have a separate instance that's running this LTE information, this LTE model. They are both currently upgraded to the 4.1.1 release. So even though the other one does not even include LTE elements, they are at the latest release for performance reasons. As I mentioned in the slide, there's been an immense discovery improvement in IT&M in 4.1.1, and I actually think it came out in like 3.9 fixed-pack 4 to 6. So that there were improvements. So right now we run those 2 domains. We have not experimented yet with the cross-domain stitcher. We've been encouraged to do so by IBM, both level 2 and level 3. So it is on our roadmap to try, but I cannot say that we've actually experimented with it and whether we had success or not.
All right. Thanks so much, Barry. Our next question, is there any way through which we can bring down the discovery to minimum across multiple domains?
You mean, in other words, break up the discovery? Because the more domain elements you have, of course, the more inter-stitching and marrying up, type of information it has to do within each discovery cycle. So if you...
Oh, no. Sorry, Barry, let me correct myself. I'm seeing here, and he said, no, the discovery time.
The discovery time. And that's actually one of the points is, in order to bring down the discovery time, one of the mechanisms, that you can do is perhaps break up your network into individual domains, and again, reaching out to perhaps some assistance from either the IT&M development group and or services would allow you to to understand what would be maybe the best way to segregate your network. And then use the feature, because then each of those individual domain blocks would reconcile themselves relatively quickly, because what they do is, if they see an IP address and it's got a certain network mask, well, it's going to try to find anything that matches on that network mask and say, okay, this device can talk to this device. So it has to do those A to Z endpoint connections, and the more devices you have and the more networks, each of those little domain discoveries is going to take longer. It's just geometric progression type of thing. So if you broke up your domains and you knew that, your west region was totally pretty much isolated, except for the core routers going back and forth with your east network, then put each one into a separate domain, run those as separate discoveries, and then do the cross-domain stitching to pick up the core common elements. So that would be one way to improve the system performance. We've asked about, actually only discovering, let's say that there's really been only activity in a certain number of network elements, and let's just say that that you had changes in this region's routers because they just went through a software upgrade. Well, you should be able to actually define a scope to just include those network elements in a discovery and do a partial discovery of those elements, and that should only refresh those elements in the database. It won't have to go out and do all of the rest of the, cross-domain or the cross-network element, marrying up and stitching type stuff. But again, I'm probably talking a little bit out of my league in that, I understand the concepts of what's going on, but of course I have not been doing any of the development. So that might be a question to raise to the IT&M development staff as to, what are mechanisms to cut down the discovery time. And as I mentioned, just going to 411 alone increased performance immensely. And then if you segregate the domains and use cross-domain stitcher, I think that may be an avenue to look at too if you have a large increasing number of network elements.
Great. Thanks so much, Barry. And our last question, how do you monitor non-IP systems with IT&M?
Actually, the mechanisms that we actually have essentially a tool that we are migrating into our Maximo platform. And essentially, when you say non-IP systems, so there is no essential way to truly monitor the information. But what you can do is if there is any mechanism that if it's, if there is some type of a configuration profile that you can receive from the device. And that may even entail a technician going out and writing down information on non-discoverable assets. So for our antennas, you can't talk to a steel antenna frame. What you can do is have a technician who, is going out there with a team to install an antenna tower. You can have them record in some type of a database mechanism or spreadsheet the information on the type of tower, how tall the tower is, what is its base altitude, how many antenna panels can it hold and support, does it need a tower light? All of those features can be written down into an Excel spreadsheet, and that's where we were using a feature known as the generic CSV collector to get that information into the IT&M discovery. So you can give it a unique name. If it doesn't have an IP address, generally I think right now, and I don't know under 411, but it always required some type of IP, so we would make it some type of bogus 10-dot number or something that we would put on the element and then load it into the database. Or we would attach that as additional attributes to an existing element, like our eNode B or our BTSs are the base stations. And if they're sitting relatively close to the antenna, what we would do is tack that information on to the chassis of the actual BTS or eNode B. So the antenna now is actually, characteristics of the antenna are just attributes that could be looked up at the chassis level of a BTS or an eNode B. So there are different mechanisms that you can employ, to sort of, either fake the system out to thinking it's totally a distinct element and use the CSV loader to load in a true element, or you can use the mechanism of like the Perl loader that's now developed to add additional attributes to an element at a particular class designation, like the chassis. So that would be my recommendations, and that's how we do it.
Great, thanks so much. And I think that's all the questions we have for today. Thanks so much for spending the hour with us, and a special thank you to you, Barry, for offering the time and sharing your knowledge with us. I know you're sharing your screen at the moment, but we have a lot of people saying excellent presentation and thanking you for your time, so we really do appreciate you spending this time with us.
Well, thank you. I definitely appreciated all the attendance and the extra questions. It always makes me feel good that they hung in there long enough to hear the presentation and ask questions at the end.
Of course. Well, everyone, please visit the TUC website where we will post the recorded webcast from today, and also join the forum discussions on topics that we discussed on today's call. So if you have any other questions after today, put them into the forum, and we'll get them, make sure Barry's able to view them and answer them. This concludes today's conference. You may now disconnect. I hope everyone has a wonderful day.
Thank you again, Robin. Appreciate it.
Thanks so much, Barry. Thanks. Bye.
All righty. Take care. Bye-bye.